Hello, everyone. Welcome. It's very nice to have you here today. Welcome to the Developer and Tech series with Astrolabs. We have a really exciting event today. We have a speaker who's going to go through Git and GitHub. He'll introduce himself in a minute. We're super excited about that. Just to remind everyone, this is a monthly series that we're doing in collaboration with Astrolabs, IBM, and Microsoft Reactor. Yeah, we hope that you can start attending every month. We also are doing this in parallel in Dubai at our office in El Quoz. So if you're in Dubai, if you're in the area, please try to stop by next time. We have a really nice in-person event happening. Today we're bringing pizza and we have a lot of free swag. So we have free mugs, water bottles, stickers, notebooks, USB drives, and a lot of cool stuff. So we hope that you can come next time. And of course, it's a great chance to network, especially if you're looking for a job or if you just want to connect with people in the tech ecosystem in the region. So hopefully you'll be able to come to a future event if you're around. And let me pass it off to my friend and partner in crime, Hossam.
Thank you, Ahmed, and thank you for having us. We're so excited to be here. And this is one of very early events in this series where we're collaborating to bring speakers and also different community members together to learn about technology and what's happening in the space, gain some experience, connect to each other. And this is a hybrid experience. So again, as Ahmed mentioned, if you are in Dubai or somewhere around like Sharjah, etc., we would love to have you over in the coming sessions. And also, if you are outside the UAE and Saudi, Kuwait, and the broader Middle East and Africa region, we are also happy to have you joining us here on the live stream. In a quick one, also beyond what's happening in the series, at the Reactors, we continue to host regular sessions on diverse technology topics, and you can find us on Meetup. Just look up for Reactor Middle East and Africa, Microsoft Reactor, and you will be able to join us on that group. On today's session, we have one of our Microsoft Learn ambassadors and also GitHub campus experts who is going to take us through this interesting topic, which is in a sense helping you understand more how you can increase your contributions and build your online portfolios. So I'm going to pass the mic to Abshar. Abshar.
Hey everyone, just give us a minute. We're just fixing his audio.
Is it okay now? Yeah. Okay, good. So yeah, hey again. I'm not sure. Is my camera all right? Okay. Okay, maybe. Okay. All right. That better? Okay. So yeah, thank you for joining again. So in today's session, we'll start off with why and how to get started with open source. So the word open source itself is like kind of like the buzz topic that that goes around in the developer space. And me as a student, again, just to give you like a broad introduction, I'm Abshar, a third-year computer science engineering student at BITS Plani Dubai campus. I'm just another student, so feel free to ask questions throughout the session, and yeah, let's hope it goes well. Okay, so as I said again, the whole open source space itself is kind of like buzzing around developers all around the world right now because of how useful open source software, code, websites actually run. So you folks might be familiar with few of these tools. Like say, for example, if there are folks in this session attending who are familiar with, say, machine learning tools, you might be familiar with libraries such as TensorFlow and so on. So open source is not something that's new, just to clarify, but it's something that is definitely worth a run. So let's go ahead and see how the session goes. Okay, so before we actually start speaking about more about open source and GitHub and stuff like that, we should actually kind of like take a step back and see what something called as version control system is. So just to give you like a broad brief about what VCS or a version control system is let me give you an example. All right, so say me as a student, we have like tons and tons of assignments. Like say for the semester specifically, we have like God knows like thousands of assignments. So say for example, if I'm working on a group project, where my professor asked me to like create say some sort of app using Java to maybe have like a GUI, like a graphical user interface, where I get inputs from a user and I give some sort of output. Yeah. So when I'm working on this huge, say a group project with my friends from university, it becomes a little trouble to maybe, sort of keep track of the changes that I've made. Say, for example, I started off with creating like a very basic interface of the the prompt that comes up for the application. And my friend goes like, hey man, there's something wrong with, the sort of like the interface that you created. And in those situations, what happens is you need some kind of way which helps you to, keep track of the changes that you make, and also some sort of system that allows you to, whenever you screw up, you need some sort of, mechanism that allows you to, take a step back, maybe go back to where you were originally, so that, things get unmessed up. Okay. So that is what a version control system or a VCS allows you to do. So as I've written here, it is exactly what the name suggests. So before we start speaking about GitHub, we come across a word called as Git. So what is Git? Git is, again, it's just another version control system that's out there, which is the most popular version control system out there, actually, as most of the developer folks throughout the world use Git to handle and keep track of their projects. So yeah, we'll get started with working on with Git first, and then we'll further move on to speak about how GitHub works and how the whole open source thing works. Okay. So as it was shown in the event, kind of like the event reminder thing that was there, we'll be trying to go on hands-on with this session, as we'll try to see how could we browse through using Git, how could we browse through using GitHub, start contributing to projects, and so on. All right. So Git, again, as I said, it's just another tool. There's nothing to get scared of. Like I still remember when I started, using Git and GitHub, although I think it was towards the first year of uni, and it was kind of frightening in the beginning because it's always that sort of environment that goes around. And one thing I just have to say though, although these commands and stuff that you'll be doing in this session might seem a little scary, but trust me, once you get used to it, it's literally a piece of cake. So let's get started. Rather than me just doing the slides, let's actually get to it. So as I've told in the sort of event thing that was there, we'll be working on hands-on. So for the folks who are in the call right now, I hope you have downloaded the Git tool. So for the folks who haven't, I'll give you kind of like So go to this link. I'm telling this for the folks who haven't downloaded the Git tool. So go to this link, which is git/sem. If I could put it on the chat, /sem.com. And you could go to the downloads page, download the tool according to what OS you have, and once you go through the entire setup, you'll have this thing called as the MinGW. Okay, so once you say, for example, if you are a Windows user, which I hope most of you would be. If you're a Mac user though, by the way, you don't have to do anything. You already have a tool on your system called as Terminal. So if you just search up in your applications for Terminal, you could by default use it. You don't have to download anything. What I'm saying here is only for the Windows user. If you're a Windows user, click on this link. You'll get us installer. Keep clicking next, and you'll have Git installed in your system. Once you have Git installed in your system, if you do search for Git Bash in your system, you will find sort of this application that's there. This is once the installation is done. So once you go to Git Bash, you'll sort of have this, interface that's shown to you. All right, and throughout the session, we'll be working through this interface, learn more about Git, GitHub, and so on. All right, cool. Also, if you have any doubts, feel free to like stop me anytime and ask your questions. All right. Okay. Let me open the slides. All right. So before we get started, we'll kind of like have to know what is sort of the the workflow that goes around with Git. So what happens in Git is sort of like, as I said, if I were working on a group project in my university, it's sort of like there's steps kind of thing that I want to do, that I should be following. Say, for example, as I said, if I was working on writing Java code or stuff like that, what I would do is make sure that after every checkpoint that I reach, say, for example, in creating my Java application, I had to create an interface first, and then I sort of had to create, the back end code, like, very complex code and stuff like that. And there are a few more checkpoints that comes along the way while creating that project. So through Git, what happens is it allows you to keep track of who made some changes, when did they make the changes, and what changes were made. So in this way, what happens is it kind of like provides you a way to, as I said, if you screw up, if you made some kind of change which messed up the entire project, you could always come back to an older version of the project and work on that version again. All right. So what happens in while working with Git is there's something called as the staging area. So the entire idea behind the staging area is what allows Git to work, and what allows the version control system to do its thing. All right. So when it comes to the staging area as well, there are two types of files which always comes into any sort of folder that you'll be working with, or a project that you'll be working with. All right. So let me go back to the terminal again. I hope everyone has it open so that we could all work together and do the thing. So once you have this open, there's this sort of a very basic command in command line, which is called as the Mkdir command, which allows you to create a directory. Directory is basically another fancy word for a folder. All right, so don't get scared with that. So when I type in, say, for example, I'm creating this Java project that I was talking about. So let's say Java project. When I type in this command, and by the way, as I said, for the folks using Windows, you'll have to use Git Bash. All right, and for the folks using Mac devices, you could just use your terminal and you could enter whatever commands I'll be typing here. Okay, so when I type in the Mkdir command along with some sort of name, what happens is when I hit enter, and this command again, I'm sorry. Okay. All right. So if I try hitting this command, which is ls, again, very basic command, you don't have to worry about what other stuff it does. But when I hit the ls command, this folder again, this /d is just this folder I have in my system. It's just my D drive. All right. So if I were to hit ls over here, once I'm done typing mkdir Java project, what happens is you have this folder that's there now, which says Java project. So to enter that folder, you enter cd, which stands for change directory. Then you type in Java project. Okay. So when I hit this, I entered that repository that's there now. Okay. That's sort of equivalent to, like, say, for example, if this is the same place that I created my folder in Java project. When I enter cd, what happens is it's just going inside this sort of folder I have here. All right. So again, we'll not be working with the file explorer, just so that you guys could get familiar with this entire interface. Okay. So now that we have created our, the folder where I'll store my project stuff inside, now what I'll have to do is I'll have to start, I'll have to tell my computer that, you know what, this folder that I have here, it's going to be something I want to be tracked, like as in the files that I have inside this folder should be tracked throughout the way that, you know, I create this project and so on. So to tell the system to make this at Git repository, what you do is you hit the command called as git init. It basically stands for initialize or whatever you folks want to call it. So when I hit git init, what happens is you do sort of notice this change that's there now. First, it was just the the folder name that was there now. Now I have this extra thing that's there called as just the master. Okay, what is the master? I'll sort of explain it as we go on through the session. All right. So what happened here as soon as I enter this command is okay. Yeah, so what happened when I sort of enter this command is it create this repository that I have over here, or the folder or the directory I have over here is initialized as a Git repository, right? So now whatever files I create in this, whatever files I change in this, my system will tell me that, you know what, there's some changes made to this. There's some something that's not being tracked. You want to click a picture of the files that you have over here and so on. Okay, so this is kind of like the start point of working with open source itself. So working with files again, as I said, the staging area is something is the main part of the entire Git version control system. So there are two types of files you will always encounter. One type of files are known as the untracked files. These are the files which basically are not tracked by Git. Yet Git again is just terminal or this entire VCS system that's there. All right. So untracked files are the files which are not tracked by Git yet, as in I've not told Git that, you know what, I want to keep track of this file that I've just created. All right. And tracked files are the files that Git is already knows that, you know what, I should keep track of the files, or as in, are there any changes made to it? Is there any deletions that's made in the file? Is there some modification that's made in the file, and so on? All right. So in tracked files itself, there are three types of files. Now, one is called as modified, as in if you have a file and you modify what is the contents of the file, as in you add stuff, you remove stuff, or you change stuff, that's when a file is called as a modified file. There's another type of file called as the staged file. So the staged file is basically, so when you have files working on with Git, what happens is for each, as I said, you want to keep track of whatever changes you make. So it's not sort of like for every second of the project that you have, it it tells that, okay, in this second there's a change made, in this second there's a change made. No, but in Git, what happens is once you reach a checkpoint, you sort of take a snapshot of the entire content you have in that folder or your repository, and in that snapshot, all the changes are saved. All right, and that snapshot itself, technically it's called as the commit, which I'll be getting into soon, really soon. Okay, so when I take that snapshot, what happens is I should tell Git, what are the files that I want to include in the next snapshot I'll be taking. Again, snapshot is telling Git, what, I've reached some sort of checkpoint, and I want to click a picture of this so that I could remember it later on. It's sort of like, say you are going out with friends and you stop to have tea, yeah, and then you want to tell, to just remember that moment, you click a picture on Snapchat and you put it up in your story so that later on as well, you could see that picture stored at this time and at this day and so on. All right, so what happens is in a staging area, you stage files. Okay, so when you stage files, what you tell Git is that when I click my next snapshot, whatever files is there in the staging area are the files that I want to take a picture of. All right, so it's sort of like, let's see, I'm making noodles, and I have all the stuff on my kitchen counter. I have water, I have the pan, I have the noodles powder, and so on. So what happens in stage is sort of like when I want to make that noodles, I sort of like mix all of them in a pan, and I kind of like turn the flame on. It's sort of like taking a picture at that moment that's there in that repository. All right, so once you have staged a file, what happens is the next step that comes on is you commit a file. Commit a file is again the next step of using a VCS. It's sort of like you're telling Git that at this moment these were the changes that were made in the entire repository. All right, so I'll show you how it goes on as I was just speaking now. I'll just show you how it goes on technically. Okay? So at this moment, when I type in Git init, I initialize the folder that I have as a Git repository. And when, say for example, if I want to start writing code, okay, so to make it a little more easier, let me not use the terminal more often. For example, this is the repository that I'm having over here as well, yeah, the Java project repository or the folder. Say for example, if I want to start writing code, but in this case, say I'm writing code in text file. I don't know why, it's a new programming language, but I'm writing my code in my text file. So let me call the file that I have as code.txt. Okay. So when I open this file, let me say this is my code, by the way. Okay, like really complex code that I'll be submitting for my assignment. This is some really complex code that I wrote. Okay, this is it. This is that complex code or line of code that I'm writing. So I know that I've reached some sort of checkpoint. I've sort of reached a point where I want to take a picture of how the repository or the project looks right now. All right. In this case, what do I do? If I go back to the slides again, we do, as I was talking over here in the staging area, what we do now is I've created a file right now, but Git doesn't know that, I should keep track of that file. All right. So there's a command called as git status. So if I type this in, it tells me that there are untracked files in the repository right now. And it also tells me the name of the file. So over here, it's code.txt. So what that means is it's a new file that I've created. Git has not started tracking it yet. And if you're making any changes, if you want to track it, what you'll have to do is you'll have to tell Git, it's not, don't keep it as an untracked file, keep it as a track file. Start tracking the whatever changes or whatever modifications are made to this file. How do I do that? There's a command called as git add. So when I do git add and the file name, if I type in git add code.txt, and I hit enter. And if I type in git status now, notice that like the first time I typed in, showed it to me as an untracked file, but now it shows me that it doesn't show me as an untracked file, but it sort of tells me that, you know what, it's a new file which is ready to be committed. As I said, commit is taking a snapshot of the repository or folder that I have. Okay? So let's move on to the next step, which is now that I've added whatever changes that I want to be made into the staging area, and I've told Git, you know what, track these files, whatever changes are made into this file, track the changes. All right. Once I've made my changes, once I've added files onto the staging area, now is the next step, which is taking the picture. All right, which is committing the file. Now let me just clear this. So to commit a file or to take a snapshot of the folder or the project that you're working on, what command you'll use is called as the git commit command. It goes as git commit. Just type in git commit, that should work as well. It opens this, let me close this up. Let me just, okay. So it opened this sort of, let me close this. Okay. It opened this sort of editor for me. Okay. Now what happens over here is it took a picture of the entire folder that I have. Now it's asking me to enter a message, as in it's sort of like you create a picture collage or like a picture, like say for example, you're posting a story on Instagram, yeah, and you want something to be written with the picture that you have. Say for example, a day out with my friends, or a day, I don't know, I'm out of words. You get my point, yeah? So here what I could write in is a commit message, something called as a commit message, which kind of identifies or which kind of tells me what all changes did I make in this commit or in the snapshot. So here I could just enter started my my Java assignment, and I save this file. I hit Control S, by the way, close the file. Once I close the file, it tells me that there is I made a commit. The commit message was whatever this is, and I changed one file, and there was one line of insertion that I made. Okay, now let's try checking the git status command again. If I type in git status, it tells me that there is nothing to commit. There's no untracked files. There is no changes made onto the repository that I have, right? So what if I try making some changes now? Or what if I want to check already what are the changes that I already made into the repository? How do I do that? I type the Git Lock command. When I type in Git Lock command, it tells me who made the changes. That is me. Like say for this example, ABXHR, that's me. It tells me when did I make the changes. It also gives me the commit message that's there. And this huge number that's there, it's just a 40 character hexadecimal number, or like a really random number, which uniquely identifies the commit that I made. So like if you have a picture with you, it has a very unique number along with it. This number that's there, it's the same number. All right. What if I want to make some changes now? Say for example, coming back to the repository I have, what if I want to write some other file of code? Say for example, code 2.txt. All right, and in this I type in this is another really complex line of code that I wrote. Okay, I save this file, close the file. In this, if I type in git status now, it tells me that there is one more untracked file that's there, code2.txt. Do you want to do anything with it? What is the Git workflow that we worked on? Let me open the slides. We did this. So we started with initializing the repository as a Git repository. That was the init command. We wrote code, we made changes, we did whatever we could. We added those files onto the staging area, and then we took a snapshot, that is making a commit. And then after this, you could keep repeating the same workflow again and again to keep track of whatever project or folder that you have. So say for example, over here, I created another file, code2.txt. If I want to keep track of this file as well, what do? Type in git add command first. Also, by the way, there's another hint or like sort of like a shortcut thing that you could do. Say for example, you have modified like a really huge project. You've modified like 10 files or like 15 files all at the same time. I can't keep typing like code1.txt, code2.txt all the way till code15.txt. Yeah. Say you just want to enter, you want to add all the files that were changed onto the staging area. How do I do that? I just enter git add dot. That dot basically represents all the files which were changed. Okay. So if I hit enter and if I check status now, it tells me that there's one more new file. Do you want to commit it? I go ahead, I commit the file. Also, by the way, remember the last time I used git commit? It was just git commit, yeah, and it opened the whole code editor that was there, and then you entered your commit message. What if you just don't want to open the code editor? You just want to enter the message over here. There's another shortcut for that, which is really useful. Which is the -m shortcut. So what happens is if I enter git commit -m, if I type in the commit message I want over here, the work is just done over there. It doesn't open up a code editor. The commit is just made. So say for example, I want the commit message to be created another complex code. Okay, and I hit enter. Creates the commit and it's done. And how do we check what were the commits that were made or what were the history of commits that were made? We use the log command. Let me clear this up. If I enter the log command, it tells me that, you know, this was the first commit that was made, an earlier commit, and this was the commit that I just made. All right. So in this way, you could want to create like really huge projects. Say, for example, there are a lot of tools which are off Facebook itself or Google. There was this other project I was working on recently where it allows you to conduct an entire election system itself, and it's all open source. And there are a lot of other open source projects that you could work on, which allows you to, sort of use this entire workflow again, keep a track of the history of changes that you have made so that if you mess up, you come back to the stable version. Okay, so this is the entire idea behind Git, but where does the open source part come in? Yeah, where does the entire contributing part come in? We'll see that very soon. One more thing to like really remember, as you get into the entire open source field, there are a lot of things that you should always try to keep in mind, which is, say for example, in this Java project itself, if I keep making changes every other second, like say for example, if I entered one character and I'd be like, you know what, I should probably take a picture of the code right now. It's going to be really hectic. As in, if I wrote a code with like 1,000 lines of code, and with each line, if I try making commit, that's going to be 1,000 commits useless. Yeah, it's going to be all hectic, and it's going to be really messy as well for others to look on. Say for example, if it was a group project, and I had my friend working on with me, if he checks out the history of code, history of changes that were made, it's going to be really awkward. He's going to be like, oh man, I can't sit the whole night going through that entire 1,000 changes. Yeah, so try not to make small changes, try not to make small commits, but don't make huge commits as well. Like say for example, you're creating a new entire version of Facebook. You can't go sitting the entire night or like 2-3 days working on building the Facebook application and then creating just one commit. Try to always make sure that once you reach a checkpoint that you think is good to be tracked or good to keep a history of, make sure once you reach that checkpoint, then only you commit, rather than making small changes or huge changes. Another thing which is really important while working with open source projects is try to write really good commit messages. Don't be like say for example, over here I said started my Java assignment, created another complex code. That's fine, but I can't be like commit message is commit one or message one or blah or stuff like that, because that commit message really doesn't convey anything to the person who's checking the history. all right? And don't feel hesitant to use Git commands. So over here, we just spoke about 4 main Git commands, but there are lots of other commands as well. Like say, for example, these are a few commands which I'll not be talking about right now. But there are a lot of other commands with which you could do really, really amazing stuff with a project and allow you to work on a project much easily and much more smoothly. All right. Okay. Okay. So let's really briefly talk about how branching works in open source or with Git repository. So branching is something really, really essential when it comes to working with open source projects, one, and with working with any Git repository. So what is branching? So when it comes to branching, it's more like, let's take the same example of the Java assignment, yeah, wherein I wrote some code which is working all good, or which is okay for a good submission, which is okay for, say, for example, like an A- grade. But my friend goes like, you know what, hey man, like I have this idea, maybe I could add this feature onto the Java project, which will allow me to like maybe get like an A grade. Okay. But at the same time, I really don't want to mess up my project as well. So what do I do in that case? As in, I don't want to mess up the main code that I have, but I really want to test out something new as well. That's where branching comes in. All right. So branching is sort of like in this picture that I've drawn. It's more like these circles that you see, those are commits that you made. So from some point of commit, you try to create like a copy of your code. All right. It's not the same code. It's like a copy of your code. And in that copy, you keep continuing working on whatever new feature you have, or whatever new feature that my friend thought about, which could get me like an A grade. Whatever feature I want, I make commits to that branch, like a copy of my code. And then once I'm done making the changes, which will not affect the main branch, what do I do? Like, say, for example, he worked on this entire feature, and he goes like, hey man, it's actually working. It's not messed up. It's not gonna get us a C grade, but the feature works. We're gonna get an A. Okay. So I go like, hey man, that's great. Let's just put the code that I have, like the code that you wrote, onto like the main code that I have. So what do I do then? So we did branching. We split up the entire Git history that we have. Now what we do? Try to merge them. All right. So it's sort of like, once you have, again, these circles are commits that you made. So once in the, say, for example, in the features branch, I made, like my friend made 2 commits, and in the master branch, there are already commits made. So once the merging is done, it's sort of like whatever changes were made in the master branch and whatever changes in the feature branch, changes were made in the feature branch, both of them merge into becoming like one code that you have, which works on stably. All right. So that's where Git branch and Git merging comes in. All right. So let's move on to GitHub. Okay, I've been talking about Git quite a lot. I've been talking about open source a lot. But what is GitHub now? Yeah, we spoke about Git. Git is again what? Git is just another version control system. Okay. What is GitHub? GitHub is, to be honest, it's I believe most of you folks might have used Google Drives. Yeah. So as I've written in this example over here, so in Google Drive, what do? You store your files that you have. Say, for example, those pictures of that you have taken with your friends when you're out. You want to put those pictures into your Google Drive. Yeah. And what does Google Drive do? It just stores those pictures or like videos or text files or whatever it's there onto that cloud storage that's there. Yeah. What is GitHub? It's sort of similar actually. In GitHub, what happens is, instead of storing pictures and videos of and stuff like that, you store Git repositories. So say we were working on this Java project, yeah, and this Java project is a Git repository. Before we started working on the Java project, when we just created the folder of Java project, we didn't have this master thing. But this master thing came out when we initialized the repository to be a Git repository. Yeah. So any Git repository could be hosted on your GitHub platform. So again, GitHub platform is just a cloud platform which allows you to host your Git repository. So say, for example, this is GitHub, by the way. Looks really cool. So say, for example, this is a repository that's there. So it says getting started with open source, yeah? And this Git repository is something that's actually there in my system. So if I go over here, the folder called as getting started with open source. And let me open that folder up in terminal, yeah? So if I go to getting started with open source, oh, okay. Okay, so if I get into this Git repository over here, which is getting started with open source, you do see this bracket thing coming up again. Also, by the way, this bracket thing, whatever it says, is actually what branch you're working on right now. Remember the first time when we saw the master branch, I was like, you know what, we'll talk about it later. So we are talking about it right now. So whatever it says is actually the branch that you're working on right now. So if you create another branch, and say you created a branch which says the branch which will get me an A grade. So when I work on that branch, which is the branch that will get me an A grade, that branch name will be written in this in these brackets. All right. Now, as we are working in the main branch itself, it'll just show me main. Okay. And as soon as it shows me main, I know for a fact that whatever repository I'm working in right now is a Git repository. All right. So yeah, we do know that getting started with open source is a Git repository. And what does GitHub do? It just hosts that entire Git repository that's there. Okay, so GitHub is just that, like, it's nothing to be cared about. Where is the slide? Okay. So yeah, GitHub is not just the platform where you could host your Git repositories. By the way, GitLab and Bitbucket are like two other really popular cloud platform which hosts Git repositories. Okay. All right. I'll get into a few of these commands to see, like, say, for example, I believe that most of the folks that's there this session, you do have a GitHub account that's created. If not, it's okay. Hop on to github.com and you should see an option to sign up. So hit sign up and create an account. So once you have an account that's created, you have an option to create repositories over here. All right. So say, for example, I want to create a new repository and I want to call it my first repository. It's not, don't worry. I have created other repositories. I want to name my repository as my first repository. Let me keep it as private for now. And yeah, I could create a Git repository from GitHub itself. Okay, all this is scary. Don't look at all that useless stuff. Don't. Yeah. So all you have to do is this link, or like the sort of like the URL that's there over here. Copy this URL, and if you come back to the Git Push that we were working on, let's say I go back. The repository that I've just created, my first repository, I want to work on that repository or that Git repository. What command do I use? There's a command called as Git clone command. So when I hit Git clone command, along with that link that I've just copied, hit enter. Give it a moment. Okay. And if I enter, like if I list all the files that I have over here, you do find that there is a new repository or a folder that's created called as my first repository. And if I get into that repository, you do find that you have the main thing that's coming up again. What does that mean? It's a Git repository. So it's it's the repository that you have created on GitHub that you're working on your local system. Okay. Now I want to make changes in this file. Say, for example, I want to write code. Let me open up this again. If I go to my first repository, and if I create another document which says okay, another text file, and if I enter something into this text file, say, for example, this is a really cool session. Okay. Session. Okay. I made some changes. I created a file and did stuff with it. Okay. Now, if I enter, what is the command that you use to check what are the changes or whatever, what is the status of the Git repository? Use the Git status command. When I hit Git status command, it tells me that there is another untracked file which is called as aboutme.txt. So according to the Git workflow that we did use, what do? Do the git add command, which adds that file onto the staging area. Once all the files that I need to be added on in the next snapshot that I take, what do? I click a snapshot, or I create a commit. And again, the shortcut is using the -m command. And if I hit created about me file, okay, that's my commit message. It is a pretty good commit message, by the way. And if I hit, if I try typing git log, you see that commit message, the commit that's made over there. Okay, but in that case, if I did make changes onto my first repository that's there, yeah, doesn't that mean that those changes should be there on GitHub? So like, if I come over here, I don't see anything. If I refresh the page as well, there's still nothing over here. All right. So what's the problem is that the changes that you've made are those changes which is existing only in my local system. It's not put up onto onto GitHub or the remote yet. Okay. So how do you do that? To do that, there's a simple command called as a Git Push command. What happens with push is whatever changes you have made in your Git repository, which is connected to a remote, in our case, which is GitHub. When you do Git Push command, what happens is those changes or those commits are pushed onto GitHub. So if I enter Git Push, wait a moment, it shows me a lot of information. And if I come back over here and if I try refreshing the page, I do see that aboutme.txt file, yeah. And if I do see that thing. If I come over here, if the button over here, if you do click that, you could see the commits that were made in the Git repository and so on. So that's sort of like the very quick way that you work on with a Git repository in GitHub, or basically getting started with using GitHub. We use the git clone and git push command, but say for example, again, if I were working on that same Java project with my friend, he would have to make changes as well. Yeah, say for example, like you could make changes in GitHub itself. Say for example, if I'm adding a file over here which says grade A or something. I don't know why am I naming it grade A, but go ahead. This project will get me an A grade. Okay, so this is just another text file. Oh my god. Okay. This is just another text file that I've created, which says which has the name grade A, and it has some sort of random text into it. Yeah. Create. Okay, let me just name it as create A file. Grade A. Okay, see. If I commit new file, created that new file in GitHub itself, yeah. But in that case, won't that mean that that grade A file should be there in my Git repository over here? If I come over here, even if I refresh, I don't see that file over here. And if I try typing the ls command over here, I don't see that file over here. So how do you get the changes that were made on a remote onto your local system? That command is nothing like we use git push, which was pushing the commits onto the remote. To get the commits from a remote, you use git pull command. So if I type in git pull, give it a moment, and it does stuff. And it shows me that there's grade A.txt file that's created. I type in, I do find that grade A.txt file created. Yeah, if I come over here in the folder also, I do see that grade A.txt file that's created. And so on. So that's sort of like the very basic idea of how do you use GitHub, how do you use Git repositories and make changes to a Git repository and keep track of whatever changes I make into a Git repository. All right. So these are really, really basic commands that we are talking about. but there are a lot more commands you could work on. Again, it might seem a little scary in the beginning. It was really scary for me as well, but then I got used to it. So so yeah, do check out the other commands that's there as well. But as you're getting started with it, these are like sort of like the very basic commands that you'll probably be working on with. Okay, now that we have spoken about Git and GitHub, we'll have to talk about what is open source at the end. So open source is nothing but, again, we saw how we keep track of files, how do version control system work, how does Git work, how does GitHub work. Now, where does open source come is that when you have projects like, say, as I was talking about the TensorFlow project. TensorFlow is nothing but a machine learning library that's there out, which is there for people to use, all right? So TensorFlow itself is open source. What does that mean? Is that people could make changes onto that entire library that's there. People could delete things that's there into it. People could add their features, make changes into that TensorFlow itself. Let me show you TensorFlow really quick, by the way. If I search for TensorFlow on GitHub, so whatever TensorFlow, or like the library that you do use on your system, that entire library is actually these lines of code or these files or these folders that's actually there. Yeah. So in this itself, like if you do come out, like you could see contributors list. So that's more of how many people and who have contributed onto this project that's out there. Again, when I do say that people could make their changes, people could delete lines, add features, and stuff like that. It's not like I could just I could just edit a file over here and it's reflected for everyone around the world. But no, but it has a sort of workflow that goes on with it. Okay, we'll talk about that workflow now. So when it comes to contributing, as I said, you can't just directly make changes into a random, really cool project that's there outside, but then there's some sort of steps that we'll have to follow. Okay. And when it comes to GitHub or with using these remotes, as I said, there's GitLab and Bitbucket as well. When it comes to this, or when it comes to the remotes, there are 4 things that usually comes in common with. One is called as issues. What are issues? It's sort of like, say, for example, I'm working on this TensorFlow library. Yeah. There's this entire section called as issues. And over here, what happens is people from all around the world, people maintaining the project or people using the library itself, they come up with feature requests or bugs that might be there or documentation problems that will be there with the library and so on. Like, say, for example, it says, let me see. This issue, it says in operation and TF takes incredibly long time. I have no idea what that means, but over here what happens is someone suggested an issue with the library with TensorFlow project that's there outside, and he or she told about whatever problem that's there. Not just problem, it could be like in this case, in this particular issue, it is a bug, but people could suggest features that could be added onto the library and so on. So in issues, what happens is you could browse through whatever could be worked on with the project and sort of like keep track with whatever changes you make onto the or whatever features you will be adding onto the project as well. Okay, so that's issues. And then comes forking. So what is forking? Forking is more of, say, for example, as I said, you can't make changes to any random project that's there outside. Yeah. So what if I wanted to make some changes onto this, onto TensorFlow itself? What do I do so that I could make changes as my own? Yeah. There's an option that does come if you have GitHub open. There's this option called as fork. What is fork? So when I do click in fork, let me click here. So when I do click in fork, what actually happens is whatever files that you have seen in TensorFlow/TensorFlow, like the actual TensorFlow library, whatever files that were there, whatever commits that were there, will sort of like make a copy of whatever that's there, whatever Git repository that was there in TensorFlow into my name. So now instead of calling it part of TensorFlow, it comes under my name. It comes as abxhr/TensorFlow. So it's sort of like a copy of the actual project that's out there. So now once that I've forked the project, what I could do is now I could easily make changes onto any file. Say, for example, this is some random file that's there, and let me edit this file. So if I say I made a change, I made a change. Okay, and I write update itself, update the file. That's the commit message, by the way, and I commit those changes. So what happened now is this is some random file that was there in this entire TensorFlow project that's there, and I made a change onto this library. And what happens is, in this case, you could do it only with a fork and not with the direct project that's there outside. So if I click on, like, this is the actual project that's there, not on my name. So if I go to the same file, I'll get an option of edit, but when I do click on edit, what happens is you create a fork and you make changes onto that fork that's there. All right. And then comes branching. So as we have discussed branching before as well, it's the same thing that we're talking about over here. But when it comes to working with open source projects, what happens is you can't directly make changes onto your main stable code that's available. Yeah, because as I said, even if I was working on a Java assignment that gets me whatever grade, whatever CGPA that's there outside, I want to make sure that the project stays stable, that the project maintains whatever stability that it had the entire time, and I don't ruin that stability by making any change or by making some feature addition and so on. So when it comes to working with open source projects, you should make sure that you always branch your code rather than working on the main branch itself. Right? So that's the whole idea behind branching. And then come pull requests. I'll try not to create the pull request from the TensorFlow change that I've made, but I'll sort of explain what a pull request is. So say, for example, in our case, we made a change onto the TensorFlow fork that we created. Yeah. So again, this TensorFlow that you're seeing right now is the TensorFlow, which is a copy inside abxhr in my name. Yeah. And we made a change in this file, the .bezel.rc, which is I made a change. So what if I actually wanted to make some, really good improvement onto the this project, which is TensorFlow. And, I had this entire idea of adding another function onto TensorFlow, which does some really, really cool machine learning stuff. Yeah. And I made those changes onto this project. And I'm like, you know what? I'm ready. I actually want this change to be considered in the actual TensorFlow project. What do I do then is, once I'm done making my changes into my fork, there's an option that comes up over here which says contribute, and it allows me to create an create a pull request. So what is a pull request is, once you have made changes onto your fork, it allows you to merge those changes, as in kind of like propose those changes onto the actual project itself. Like over here, if you look, it says that the project is from Upshur or like abxhr / TensorFlow, and it is trying to merge with TensorFlow, like the actual TensorFlow project itself. So when I create a pull request, again, it doesn't directly merge the changes onto the actual project, but it's sort of like creating a proposal to make some changes. All right. So I'll show you a few examples of pull requests that were created. So if I hop onto TensorFlow itself, if I check pull requests, there are a lot of pull requests that's there over here. Yeah. Say, for example, let's check this random pull request that was created. So what happened is some person created some changes onto some file in TensorFlow, and they wanted to suggest this actual change onto the actual project that's there outside. So the person made their changes, opened a pull request, kind of like told whatever changes that they made or whatever fixing that they did or feature addition that they did, and then they're just waiting for someone to, like, someone as in a maintainer of the project. Like, obviously TensorFlow is not a project of its own. It'll have someone maintaining the project, keeping track of what is to be added onto the project or what is not to be added. So once the pull request is done, what happens is a maintainer of the project will come, check whatever changes are made. Like say, for example, if I do check this, there's few changes that's made over here. The green line says that there were a few additions made. The red line says that there were a few deletions that were made. So these are the changes that was made in this pull request. And the maintainer of that project could always allow to like merge those changes into the actual TensorFlow project itself. All right. So that's the whole idea behind pull requests. Yeah. So again, as we spoke about the Git workflow, there's a whole contribution workflow itself, kind of like sort of like the summary of what you'll do while working with open source projects. So again, we started off with when we were working with TensorFlow, we started off with forking the project. Yeah, we first created a fork from the actual project, and then what do? We made changes onto it. In the slides, I do see it as clone, but in my case, I just made those changes directly from GitHub itself. Yeah, but when you're working on actual changes, you'll want to take that project onto your local system, open it in say maybe like VS Code or something, make the changes, and then what do? Again, as I was talking right over here, we're talking about branching as well. So when I make new changes, I want to make sure that, say for example, if it is fixing a bug or suggesting a new feature, I want to make sure that I don't do it directly onto the master branch. So once I clone that fork that's there, say for example, let me find the fork that we just created. Hello. This was the fork that we just created, and clone the to clone this fork itself, click on code. Again, you find a link and hop onto git bash or whatever terminal you're using, git clone, and along with whatever link that you just copied. So once you clone it, what do? Create a branch inside that clone or whatever. Like say for example, once I do clone it, give it a moment. Oh no, it's a huge project. Let me not do that. Okay. So once you do have that project into your local system, what you want to do is, instead of making your changes in the main branch itself, make the changes in some branch that you create. Yeah. And then once you create a branch, made your changes in that branch, what do? Next step is obviously taking the picture. That's the making the commit part. So you make your commit, and obviously it's not limited to one commit. You could make 5 commits. You want to make 100 commits, go ahead, do it. And then once you're done making all the commits for that particular fixing the bug or adding a new feature onto that project, what you want to do now is you push whatever is there. Like say for example, I clone the project into my system. What do? Put those commits or whatever changes I made in my local system into a remote. I use the Git Push command. So I push those commits into my actual fork itself. I'll have the changes that's over here. Once I have all the changes that's been done, what do? I create a pull request, which creates kind of like a proposal for the maintainers of the actual project. So again, you open a pull request, and then you could type in whatever information you want. Like say, for example, if I click on create pull request, I could give the pull request a name, some random change. Don't do this though. Don't create random changes into huge project. Create some does some random changes. Blah. No, I'm not gonna type that. So you kind of like brief them about whatever changes that you made, whatever proposals that you want to make. Then you click on create proposal. Someone from some of the maintainers of the project itself will kind of inspect it, review it, and then check if that could be merged on with the actual project. So yeah, that's the end of that contribution line that's creating the pull request. Then the last thing to talk about is best practices. So when it comes to working with open source projects, it's not just that you be good at writing code or be good at, like I know five programming languages and stuff like that. It's not just that, but obviously you could be proficient in some programming languages, but you have to make sure that you are good at contributing as well. And contributing, as I said, it's not just about your skill, but it's about how do you approach open source itself. So when you, like, say for example, if I was working with TensorFlow, yeah, the first step that I have is always make sure that you check the project well before you start making your changes. And if they have documentations or guidelines that's available with them, try to read them before you start, working on making your changes to that project. Like, say for example, in TensorFlow itself, make sure that whatever README file or whatever documentation that they might have, make sure you get familiar with the project itself before you jump on, be like, okay, let me add a calculator onto the TensorFlow. Make sure you don't do that. All right. Another tip I have is make sure to run tests on your code. So say for example, if I again coming back to the really old grade, getting a grade on my Java assignment, I want to make sure that when my friend does, propose some changes onto the project that we're creating, that the whatever proposals or whatever changes that he's requesting is something that I could merge on eventually onto my project, and that whatever changes that's made won't cause any problems later on as well. As in, there's no probable downfalls that will come with those changes. So make sure that you run tests on whatever changes that you're making. All right. Another good tip, we did repeat this good best practices when we did in the beginning also. Write good commit messages. It's really, really important, because I've worked on few open source projects myself, and I've seen like when I've worked with few folks, there are few when it comes to writing Git commit messages, some of them are like really, really terrible, and it gets really hectic to sort of navigate through the entire project, see what changes were made at what point of time and so on. So make sure that you write good commit messages, not for yourself, not just for yourself. Obviously, it's for you to know what changes you have made when, but it's also for others to see, what changes were made when, and kind of navigate through whatever, how the project has been maintained the entire time. And the fourth one, which is really, really important, be open to feedback. So when you get started with working with open source or making your contributions onto open source, like say, for example, in GitHub itself, in the beginning, you go like, I have these changes that I have to make. I created a pull request and so on. And in the beginning, the maintainer itself might go like, what, the proposed changes that you have made might not actually be good for our project, because it might cause other problems or and stuff like that. And it could be a little demotivating at beginning, but what you have to notice is that the maintainers don't do it just for the sake of the project itself, but it's for the sake of learning as well. The whole idea behind open source is not to create a competitive environment around us in the developer space, but it's more of to create a collaborative environment around in the developer space. So always be open to feedback. And even if you have, say, for example, if you have proposed some changes, the maintainers of that project might come up ahead and be like, what, the changes are good, but maybe you could add this change more, or maybe you could delete this small line of code you have written and stuff like that. When you do come across that, don't feel demotivated and stuff like, oh, I'm a really bad programmer, I can't do this, I can't do this thing and stuff like that. But be really open to feedback, and it'll really, really help you on the long run. Okay. And the last one, feel free to ask questions. This is really important as well, which people can like dodge upon while working with open source. So when it comes to, like, say, for example, if I were actually contributing to TensorFlow itself, and I'm not really sure where do I start with, where do I find some problem that I could actually fix, or where could I find some feature that I could actually make changes upon. When I'm in those situations, or when I actually need help, it's actually okay to ask those questions. So when it comes to a lot of projects these days, what happens is they usually have a forum kind of thing. It might be on Discord, it might be on Slack, whatever it is. When it comes to those things, it's okay to ask the maintainers of the projects questions, and it's good to ask as well, because doing so will help you learn more about contributing into open source and being a really good programmer. So yeah, that was pretty much it. Also, for the folks who are listening in, I won't be, there was this sort of thing that I created, which I'll really pitch in really quick, so that you folks could make your first contribution. So the repository that we were talking about earlier, which was getting started with open source, you could find this on GitHub if you just search for abxhr / getting started dash started with dash open source. Because this repository, once you do come to this repository, find this website that's there. So onto this website, this is just a dummy website I have created, with which you could actually practice making your first contribution. So I've made few dummy issues as well, which will allow you to maybe actually test out the stuff that you have learned from this session. So one issue that I would suggest really working upon as your first contribution to GitHub and open source is the add yourself to the website contribution. So I've written the steps that you could follow. It's really, really simple. And you just have to use like 20% of what I've thought over here to actually do this change, make these changes. So I've written the steps. Make sure you follow those steps. And what this feature, this issue itself was supposed to do is, say for example, in this website, you could add yourself onto the into the page. Like say for example, I've added Upshur, which is me, by the way, and you could maybe write something little about yourself over here, maybe a few contact details so that folks could reach out to you. And this could be your first actual open source contribution out there. There are a few other issues that I've opened as well, so feel free to make use of that issue, make your contribution, and so on. So yeah, that's pretty much it with this session. Also, if you have any questions, stuff like that, feel free to drop in a message to me or reach out to me. I really don't mind answering questions. So these are the places where you could reach out to me on. Email me. I'm really frequent. I do check my emails quite often. LinkedIn is also fine. GitHub, you can't message me, so I'm sorry. So yeah, reach out to me on these, and I'll be happy to help you guys. Okay.
So much for that. That was like a proper class. So yeah, really appreciate it. All right, thank you so much. We're going to do this, like I said, once a month. So if you're in Dubai, we hope that you can come to our next session that we're doing. It'll probably be on the 22nd of March. So stay tuned for that. In the meantime, yes, if you entered your email on Meetup or anywhere else, we'll send you a recording of this. You can also watch it on any of our social media channels if you want to rewatch it, or if you didn't see all of it. And yeah, we hope to see you in the next one. Thank you so much.